I wouldn't be right in the head. Therefore, it is impossible to get up to date. Let's go back to one of the earlier graphics and look at what I know now as a professor. I work on the active transport of calcium, a very limited area. And in terms of knowledge, I am approximately up to the year 2000. If we move to a more general area, like immunology or parasitology, areas very similar to mine, I would be in 1980. My physics, probably Sir Isaac Newton. Math, around the year 1200. In social science, I'm not sure exactly at what point in history I am, but my two daughters, when they're angry, often say that I'm in the Stone Age. However, I do have a profile of various cultural periods in my head. Similarly, each one of us has a different profile of knowledge throughout history, and it has become very difficult to find two people who think in the same way, which was not the case in ancient times. We have difficulty, therefore, in handling this huge quantity of information generated every year, which forces us to super-specialize. Super-specialization is something new in history. Between 1700 and 1900, the amount of information available could easily be absorbed by the human brain. There were few things known, and people were generalists. A classic example is René Descartes, a great philosopher who described the scientific method. He was a great mathematician, discovering the Cartesian coordinates. And besides this, he was a famous biologist, the first to observe that the hypothesis has an intimate connection with the brain. It was possible, therefore, to absorb all the scientific knowledge available in that epoch and use it in a generic form. Nowadays, with the great quantity of information available, it has become impossible to assimilate everything that is discovered each year, and this leads us into super-specialization. But super-specialization has complicated consequences, as we can see from the illustration here at the side. The great areas of knowledge can be grouped generically into the social sciences, exact sciences, and education, a science whose importance has grown with the excess of information. The exact sciences group those areas of knowledge in which observation can be supported by experiment. In the social sciences, other methods are needed to prove an observation. Experimentation here is not as feasible as in the exact sciences. Finally, education is the transmission of knowledge. Up to about 150 years ago, what was known about these three great areas of knowledge was little, and all of it could be grasped by the human mind. Nowadays, with the large increase in knowledge, they have become sealed areas, great nations with little intercommunication. Workers in the exact sciences are used to thinking that social science is only more or less science, because it can't be proved in the same way as the exact sciences. On the other hand, social scientists believe that those who work in the exact sciences are rather limited, with little flexibility. As for education, things are even more complicated. Little research has been done on the way to transmit to or teach young people everything that we learn each year. In reality, here in the 21st century, we are still teaching like Plato and Aristotle taught in the Lyceum and the Academy in ancient Greece 400 years before Christ. We teach theory, practice, and experiments, just like the ancient Greeks, and the principal preoccupation is the transmission of information. For us to have an idea of the difficulty with education, if we count the number of publications in all areas of science, the number of publications on education is less than 1%. so little emphasis is given to teaching. But even in the great areas of knowledge, as for example the exact sciences, there is great difficulty in communication. The way in which biologists see the universe is certainly different from that in which the mathematicians see it, and the mathematician from the physicist, and so on. Super-specialization is such that the language of the mathematician does not permit him to transmit clearly to the biologist the way in which he sees the universe. And the same goes for the biologist, to the mathematician, and the physicist. As a consequence, our tendency more and more is to deepen our knowledge in a specific area with little lateral spread, little communication between the areas of knowledge. Perhaps if we could achieve a universal language in which the mathematician, the biologist, and the chemist could communicate with clarity, each one transmitting to the other the form in which they see nature and the universe, our knowledge would advance much more rapidly. Unfortunately, we have not yet discovered this universal language, which would permit full and clear communication between all the areas of knowledge. So nowadays, among the difficulties that confront us are those of dealing with the enormous amount of new information, super-specialization, and the lack of a universal language that permits full communication between the different areas of knowledge. But, like all the great challenges that we have already met and overcome throughout our history, certainly we will be capable of overcoming these obstacles and following our journey in search of understanding nature.